Alrighty then, corn children, children of the corn. It is a fine day for mathematics, and we are going to be looking at the slope of a line. Here's the deal. Lines can be described, and not just by saying they're straight. They're all straight. I know, right? So the question is, how do we describe a line? Well, we can use the concept of how slanted it is. Is it a very steep line? Is it a shallow line? Does it go uphill? Does it go downhill? That concept of the slant of a line is called slope. So let's look at an example together. Pause the video and get this written down. Yeah. I have here a line, and I have labeled 3 points on the line. And I would like to describe the slope. Well, there's a couple of different ways that we can arrive at the same answer for slope. Here's the first way. There's a formula. We can think of slope as how much the line rises over how much the line runs. Rise over run. Now, what the heck does that mean? Well, rise and run both start with R, so that gets, the alliteration is nice. But what does it really mean? We're going to measure the uppy-downiness and put that number in the top, and I'll show you how. And run is the horizontalness, the righty-leftiness of the line. And I'll show you how to do that, and we'll write that down. And then we'll get a fraction, and that fraction is the slope. All right, so how do we do it? Here's what we need to do. We are going to find any 2 points on the line. Any 2. Hey, I found 2. I know, right? They're labeled. I'm going to be using, now I know there's another one, but hold off. Don't use that one yet. Not yet. Shh. I'm going to be using these 2 right here, the first one and the far left one, the far left and the far right one. And I am going to count the rise and the run to get from one dot on the line to the other dot on the line. Yeah, let's go. So here's what I've got. Starting here at -3, -1. In order to get over there, I would need to go up or down, but in this case up, 1, 2, 3, to put me at the same height as that dot. I'm going up 3. All right. And then how far over, or my run? How far would I need to run horizontally? Well, I just count. 1, 2, 3, 4, 5, 6. Now I want you to notice that we are going to the right. So I'm going to write W-R-I-T-E, R-A-G-H-T. That's funny. I'm going to go right 6, up 3, right 6. Do y'all see where I'm getting those numbers? Oh yeah, I made a little triangle there, up and over, from a dot on the line to a dot on the line. All right, now what do we do with these numbers? In our slope formula, it says to put the rise number in the top. Now, we do have to think about positives and negatives. Corn children, would you agree with me that if you are going up, you are moving in a positive direction? Yes, that seems intuitive, doesn't it? Up is positive. If we were going down, we would be going in a negative direction. So because this one is up, it is a +3. So I'm going to take the formula and I'm going to write it on the other side. The rise number is up, or +3. And then the run. Well, the run number is 6. But again, we have to consider positives and negatives. Would you agree with me that if you think about the x-axis, that the positive side is to the right and the negative side is to the left? Yes, that seems kind of intuitively obvious. So because we are going right 6, I'm going to be using a plus sign again. So my run number is +6. I know. This value is our slope. Now, of course, yes, of course, we can reduce this. I can divide the top by 3, I can divide the bottom by 3, and I get 1/2. our slope can be reduced to 1/2. Now, I just picked these 2 dots. I could have chosen different dots. I know, right? Consider if I'd chosen the dot 1, 1 and 3, 2. And what if I didn't want to go up and right? What if I wanted to go down and left? Would I get a different answer? No! I know, it's crazy. Check it out. Any 2 dots. Start at any dot, land at any other dot on the line. If I start at this dot, I would go down, so negative, 1, and I would go left, so negative is left, 2. If I again use rise over run, the uppy down number in the top, hold on, put it right here, it'd be -1, that's the, whoops, I'm off the screen, -1 in the rise, and -2 because it's left in the run. But wait a minute. What happens when you have a negative divided by a negative? You get a positive. These are equal. You can reduce the negatives by canceling a negative divided by a negative. Those will cancel, and you still get positive 1/2. So as long as you are putting the up and down number on the top and the righty left number on the bottom, and you reduce it, we will end up at the same value. Doesn't matter which dots you use, any dots on the line will give you your slope. Well, hey, that was so easy. Yeah, you know why this was easy? Because I already drew you this picture. If you have a graph of a line, you can literally count up and over. Unless, of course, the dots were really far away. What? Well, what if these dots were like really, really far away and we would have to count like up 400 and over 37? That would take a lot of time, right? I wonder if there's another way that we can do the rise over the run. There's a formula. No freaking way. Yeah, way. Come along. On this next example, I am not going to show you a graph of the line. I am going to tell you 2 points on the line. All right, so here we go. Right, or instead of right, maybe find. Find the slope of the line that passes through the following 2 points. Now, I'm going to write them down, one over here, one over here. If you're taking notes, and you should be, you should do the same. So I'm going to put 1 point here. This is the point -4, 2, just making up stuff, and 3, 7. Yeah, I just made up those numbers. I did. I just made them up. Couldn't stop me. Now, I could plot these and then start counting, but if these numbers started to get large, and they could, then you might have to count a lot, and I don't want to have to do that. So here's what we're going to show you. There is a formula to find the slope. Write it down with me. Here we go. Slope equals. Now, we should not be surprised that it's a fraction. After all, we already know there's a rise part in the top and a run part in the bottom. Here's how you can figure out the rise without actually counting all the way over. Write it down with me. Y sub 2 minus y sub 1. Those are little teeny 2's, little teeny 1's. I'll talk, don't worry, I'll explain. In the bottom, x sub 2 minus x sub 1. All right, now what is this? Pause the thing, write it down. All right, what does this mean? What is going on here? Well, let's look at this. We have been given 2 points. Yes, there's a first point and a second point, 2 points. Each point has an x coordinate and a y coordinate, an x and a y. And so I am going to keep them straight by doing the following. You ready? Here we go. Since this is the first point, well, let's do this. This has an x and it has a y, doesn't it? Yeah. This one also has an x, and it has a y. They always come in that order, the x coordinate, then the y coordinate, alphabetically. But so that we can tell them apart, on the first point, I put little ones. Oh, that little x with a 1 means the first x, or the x of the first point. The y with the little 1 means the y coordinate on the first point. So guess what we do on the second? Yeah, you already figured out. We put little 2's. So this is the second x coordinate, or the x coordinate on the second point. And this is the y coordinate on the second point. So now, in my formula, when I see x sub 1, I'll replace it with -4. When I see y sub 1, replace it with a 2. When I see x sub 2, put in a 3. When I see y sub 2, put in a 7. So let's do it. All right, here's the formula. Now, people, help yourself out. There are minuses in the formula. We put minuses in the formula. So you set yourself up. You draw your fraction line, you put your minuses. All right, here we go. It says in the top left to put y sub 2. Whoop. Y sub 2 is 7. So I will replace this y sub 2 with a 7. Yeah, it's just that easy. I know. Then there was our minus, we already wrote it. And then there's y sub 1. Y sub 1 is the number 2. Look, there it is. So I put a 2 right here. Awesome. Don't forget your denominator, x sub 2, the second point's x, the x coordinate from the second point. Look, it's labeled. I labeled it. I hope you did too. There's a 3. And then it says x sub 1. That is the x coordinate from the first point. Oh, now look. Do you see it? Do you see this? Look right here. It's a -4. Wait for it. The formula has a minus, and the x is negative. So there's minus and negative. So just be careful. There's 2 of them there, minus and a negative. All right, so how do we math this out? Well, you do the top like a little problem. What's 7 minus 2? 5. Awesome. Down in the bottom, minus a negative, we treat like a giant plus, and this is 3 plus 4, or 7. The slope is 5 over 7. Yeah, it is. All right, one last thing here, and I know this is crazy. When we work with lines, and we are, and we talk about the slope, instead of writing the word slope over and over, because that's 1, 2, 3, 4, 5 letters, we don't like to do that. I know, we're too lazy. So it is standard practice to not use the whole word slope when we talk about it. Instead, we use one letter. It's not S, it's not L, it's not O, it's not P, and it's not E. I know it's crazy. Here's what it is. You ready? When we talk about slope, we use an M. Yeah, you were going to guess that, weren't you? It's true, though. When we talk about slope, we use the letter M. There's a reason, but I think of it like mountains, mountain slope. So M for slope. Our M value, our slope value, was 5 over 7. Enjoy that.